Hello, my name is Enrico and I am a data scientist at Logivan. In this video series, we will introduce you to some Logivan AI products, such as our recommender system and our chatbot. Today, I'm going to talk about REal, our new recommender system. REal means Recommender Engine for logistics and of course for Logivan. In our database, there are tens of thousands of orders for a possible driver at a given point in time. And there are so many factors to consider. For example, which are the driver's preferred routes, which is the driver location at this moment. A human being cannot possibly understand which is the best order for a given driver. That's why we have REal that will act like a smart fishing reel, powering the rod to fish the best orders for a given driver in the Logivan'S order lake. The traditional way to find suitable driver for an order in the logistic business is simply to call up as many drivers as possible until one responds. This is very time consuming and also it does not ensure that the best driver is found for a given order. Instead, we built REal, which is a totally AI-based recommender system, which will ensure that the best driver is found for a given order. I know you were impatient for the technical stuff, so let's dig deeper into how our recommender system works. We use state-of-the-art algorithms to solve this problem. We reframe the problem as how similar is each order to each driver. So basically we want to rank the drivers in terms of the similarity to a given order, or vice versa, we want to rank the orders in terms of a similarity to a given driver. But how can we compare drivers and orders? Aren't they two completely different entities? Isn't it like asking how similar is this house to this car? The secret is in neural network embeddings. You know how boring computers are. They like just zeros and ones, right? But sometimes this can be very helpful. In our case, we can represent each variable, for example, the routing history, as a vector of numbers, so that they can be understood by our algorithms in the Euclidean space, no matter what they are. Embedding weights are learned to minimize a loss function. This means that our algorithm is thinking, how can I best represent these features numerically so that I can make good recommendations? So as with routes, or houses and cars, any variables can be represented as a vector of numbers. Now that we have comparable numerical representations of the driver and the order, we can finally answer the question, how similar is this driver to this order? So how well does this approach work? We have plotted the distribution of the three principal components of our data. We can see that our model has been able to separate two classes very clearly. One class is made of the biddings and the clicks that are the orders that the driver has opened in the app in the past. And the other class is made of the orders that the driver has never opened in the past. Thus, we can be confident that our model has been able to separate between orders that are interesting for the drivers and orders that are not interesting for the driver. I do not want to bother you with evaluation metrics too much, but I just want to tell you that they look really good. Let's take accuracy, for example. Every time we answer the question, is this driver similar to this order? How many times did we get it right? 75% of the time. This is really good for a recommender system. Another metrics I can show you is about novelty. So 56% of the time, our recommender system not only made a good recommendation, but also made a recommendation that had a new route inside. This means that the driver is able to find new interesting routes and thus find more jobs. Okay, let's take a look at the more intuitive example. We have given one driver and 1,000 orders to REal. This task could never be done by a human in a reasonable time. On these maps, you can see three examples of drivers. The yellow circle represent the driver's current location, and the black arrows represent the driver's routes that they have explored in the past. So you can see that REal always recommended routes in green and red that are around the area that the driver likes the most and also around the driver's current location. Conversely, the routes that are represented in blue are the ones that REal did not recommend, and you can see that they are very far from the driver's usual area. These scatter plots represent results for 150 drivers. Let's take a look at the plot on the left. This plot represents the route length for the driver's history on the x-axis and for real recommendation on the y-axis. We can see that in the top plot, that are the top 10 recommendations, there is a relationship, a positive correlation. This means that drivers who in the past like to go long routes are also recommended longer routes by real. This is very interesting, and the same pattern we can see it in the right plot on the top, again the top 10 recommendations. This plot is about the distance from the current location to the pickup point. From this, we can assume that real is actually learning the driver's preferences and not just blindly recommending the routes that are around the driver's location. It is actually an intelligent machine. There are several advantages of an AI-based recommender system. First of all, real will accelerate work. Everything will be automatic, and the time between posting an order and finding a suitable driver will be reduced. Also, real will cut costs for all the stakeholders in the market because there will be no middlemen and there will be less human work involved. Finally, and most importantly, real will help drivers finding more and more jobs because good recommendations means that drivers will find more suitable routes for them. As Logineers, we are so excited to always promote innovation through AI and technology. In the next videos of this series, we will talk about Logivan chatbot and pricing model. I am Enrico, and this was Real, our new recommender system. Thank you so much for watching. See you later.